Hello, today is Thursday, February 13th, 2019. I'm Joe Schmidt from TC2, and this is Staying Connected. Last week, David Lee, TC2's technology director and a good friend of mine, David and I, we published a paper titled Catching the 5G Wave. Now, 5G is an important topic for enterprises, and while 5G may not be widely available in 2020, at some point it will be, and you need to be ready for it. So using the paper as the basis, we're recording this two-part podcast series. David and I will discuss what 5G is, what it means for the enterprise, and we'll lay out what you need to do in 2020. On this episode, we'll describe what 5G is and how it technically differs from today's 4G technology. Okay, David, thanks for joining me, and let's get started.
Joe, it's great to be here as always. Thanks for the invite. Definitely not for the audience out there talking about surfing, even though the wave is in there. It's not a new surfing technology and wireless service discussion here. So, when 5G reaches critical mass, it truly will be revolutionary, but we're still not there at this point.
So why is that? Why will it be revolutionary?
Well, Joe, 5G is the newest but also evolutionary wireless technology that promises speeds 10 to hundreds of times faster than what most users receive today with 4G LTE. In practice, today's 4G networks can deliver speeds of anywhere from 10 megabits per second to 50 megabits per second in most urban or ex-urban environments. Theoretically, 4G LTE can reach a download speed of 150 megabits per second. But with 5G networks, on the other hand, they promise a speed of 1 gig and could theoretically hit a peak download speed of 10 gigabits per second, possibly higher as the standards evolve. So 4G ushered in the ability for wireless users to download movies, gigabyte-sized files in minutes. It enabled the seamless streaming of music, video conferencing anytime and mostly anywhere, stadiums, in their homes, etc. Users were able to make high-definition voice calls using voice over LTE, for example. But 5G will take all of this up another step, one very big step.
Okay, so it's a lot faster than 4G, but what else makes 5G so special?
What's important to understand, Joe, is that 5G is not a minor revision to the existing wireless technology or a rebranding of a faster version of 4G LTE. We've seen that, as you can imagine, not just here in the U.S., but globally with the wireless providers rebranding and using a lot of marketing. But 5G requires the service providers to buy and use more and different wireless spectrum based on the 5G standards. And that's very critical because the 5G standards really make this a real stair-step increase in technology and capability. It also requires a lot more infrastructure, more cell sites, antennas, different antennas, hundreds of thousands of antennas, given the frequencies, we'll get into that later, base stations, and fiber optic backhauls. So 5G also requires a fundamental redesign of the wireless service provider's edge and core networks, with edge servers close to or at cell site locations to minimize latency for real-time applications.
All right, now for cellular services, it is all about spectrum, which are the radio frequencies used by the cellular network service providers to deliver their services. Now that's a simple description. So David, do you want to go into more detail about spectrum and how 5G uses the wireless spectrum?
Sure, you bet. 5G is based on the 5G NR. NR meaning New Radio Standard, which has been adopted by the Third Generation Partnership Project, or 3GPP. It's a bit of a mouthful, but what's important for the audience to know is it's the international standards organization responsible for the development of GSM, the initial, if you will, standards, 2G, 2.5G, 3G UMTS, and 4G LTE, which we're using now as a standard. So the 5G NR networks operate on different frequencies, described in the 3GPP in two frequency ranges, or FRs, defined as FR1, which is really a wide swath of different spectrum frequencies starting at 410 megahertz to 7 gigahertz. So that's quite a lot of bandwidth. And FR2, 24 gigahertz up to 52 gigahertz at this point. So those are defined as at the low and the high ends of the spectrum. So you can see this is a revolutionary or evolutionary definition of different frequency spectrums that are allowed to be used in 5G, including the frequencies vacated by decommissioned wireless spectrum from commercial and government communication services. For example, in the U.S., the U.S. Navy radar is located at 3.5 gigahertz, which will be shared with future 5G wireless providers, as an example. So the U.S. government, as well as other governmental organizations around the world, coordinated over these last many years in order to free up these spectrums, whether on a permanent basis that's vacated or on a shared basis using artificial intelligence and deep learning algorithms to properly share with these governmental organizations. In practice, these two broad ranges are further categorized as low, meaning below 1 gigahertz, mid-range, 1 gig to 6 gigahertz, and high band, 24 gigahertz and above spectrum. The high band in particular is referred to as millimeter wave spectrum. Based on early implementations and announcements by wireless carriers, deployments will be in the low band and mid band spectrum space. There is ongoing research using the millimeter wave frequencies given the connectivity challenges and trade-offs for this spectrum.
So that high band millimeter wave spectrum, is that the one that's going to deliver the 10 gigabits per second speeds that we mentioned?
Right, that is correct, Joe. While 5G deployments that use millimeter wave frequencies allow for much faster data speeds, the end users and CIOs out there are challenges that must be resolved. As an example, typical challenges are signal quality due to the lack of millimeter wave signal to penetrate buildings or homes, rain fade, atmospheric gases, distance in terms of the signal loss over greater distances, what's something called multi-path interference without getting into details, and even trees and foliage to get through, which as you can imagine have water in the foliage, to get through that could cause interference and signal degradation as you're moving around in a suburb or in your car in a city. So established techniques that can mitigate these effects that are well known over the last 40 or 50 years and been in use by the military include massive MIMO, that means hundreds of transmit and receive antennas to support dozens of end user devices, beam forming and beam tracking antenna technology, as well as adaptive modulation, coding, and power control. The typical challenge with millimeter wave frequencies occurs with moving users. For example, the signal may dramatically be impaired when a mobile user, say in New York City with high rises, turns a corner, goes around the block due to buildings and the signal's blocked or other structures blocking them, or if they go down into a parking structure underground, they can lose that signal. But for a fixed site, such as an office building or a stadium, the end user location is fixed in relation to the antenna beam. So the radio signal and antennas can be optimized in the 5G millimeter wave context to maintain a strong signal.
So, David, once the wireless service providers have this radio spectrum, they still have a massive undertaking to augment their current networks, and they have to add a ton of new infrastructure and other resources.
Right, they sure do. They're all aggressively building out their wireless access networks and, of course, marketing them and selling them. And companies such as Ericsson, Nokia, Samsung Electronics, Cisco, Juniper, and Qualcomm are key providers of 5G wireless equipment and chipsets.
So let's talk briefly about Huawei, which is a Chinese communications equipment company. If you follow this industry, you know that Huawei is considered the leader in 5G technology, and it is also considered a real threat by the U.S. government. So why is that? Well, the company was founded by a former Chinese military member who is also a member of the Communist Party. The U.S. has charged the company's CFO with financial fraud and is trying to get her extradited from Canada to the U.S. That CFO, she's also the daughter of Huawei's founder. So, David, lots of suspicion and intrigue around Huawei.
Well, Joe, there sure is. And, now outside of the U.S., one of the favored potential 5G equipment providers is Huawei, as you mentioned. However, as recently as last month, as an example, the German government had not approved and still hasn't approved in their legislature Huawei as their future 5G equipment provider. And Australia and Japan have banned Huawei based on the U.S. government's recommendations. But under Chinese law, it's important for end users and enterprises to know that Huawei and other Chinese companies are required to comply with their 2017 National Intelligence Law, meaning companies could be forced to hand over network data whether they want to or not. The U.S. government worries that Huawei, at the direction of the Chinese government, could carry out surveillance or launch a cyber attack using its 5G equipment. So U.S. service providers are prohibited from using Huawei equipment at this point. As reported in the Wall Street Journal just this past Tuesday, the U.S. government intelligence agencies has revealed highly classified information that Huawei does have backdoors, and that's what we've been communicating to our allies, such as the UK and Germany, where the mobile network operator would not be aware. According to the article, these backdoors have been observed by the U.S. intelligence services since 2009 during the early 4G deployment. So this is not something new, but it's new that they've publicly released this knowledge. And moreover, the U.S. government now has announced that Dell, Microsoft, and AT&T are being encouraged to develop a 5G solution that is more software-based and would potentially eliminate the need to use Huawei's equipment outside the U.S.
So what else will service providers need to do to deliver 5G?
5G is also going to require the network service providers to push more of their processing to the edge of the network. Service providers are already preparing the core of their networks to handle the anticipated volume of traffic growth by deploying software-defined networking and utilizing network function virtualization, NFV. They're also developing the means to dynamically allocate required bandwidth and processing resources that will allow them to offer much lower latency and higher availability service levels.
Okay, thanks, David. Now, David and I will be back with part 2 of this series, Catching the 5G Wave, where we'll look at what 5G means for the enterprise and what we recommend you do in 2020. In the meantime, if you do want to discuss 5G or you have other ICT needs, you can contact David, me, or any of our LB3 and TC2 colleagues by giving us a call or dropping us an email. You can also subscribe to Staying Connected on Apple, Spotify, Google, and lots of other platforms. We also encourage you to check out the content on LB3's and TC2's websites and to follow us on LinkedIn.